Let's subscribe,
like, share, and leave the comments behind.
Welcome to our channel. In this lesson, I want us to discuss 2017 Kcse Chemistry Paper 3. That is question 2. This is a question that students find a lot of difficult to answer because it was a descriptive technique kind of question, whereby you are given some reagents and you are told that a certain solid is expected to be a certain salt. Therefore, you come up with the procedure and you describe now that procedure. Afterwards, you will carry out the test. So in this question now, we are given solid K, we have aqueous ammonia, we have aqueous sodium sulfate, we have dilute nitric 5 acid, and then you have wooden splint. Then you are told solid K is suspected to be lead 2 carbonate. So the trick here is you need to know whether that solid K provided is a soluble salt or not. So if it is a soluble salt, then you must be given distilled water. Therefore, you dissolve first in water. But if it is insoluble salt, then you will use dilute nitric 5 acid to dissolve that solid. Therefore, the other thing that you need to note is where you will use each reagent. For aqueous ammonia, aqueous sodium sulfate, dilute nitric 5 acid, and wooden splint. So I said that first you come up with the procedure, that you describe the procedure, then afterwards you will carry out the test using the procedure that you have described in above. So in our first test is to solid K in a test tube add dilute nitric 5 acid, add dilute nitric 5 acid, and test any gas produced using a burning splint. Then you divide the resulting solution into two portions for tests 2 and 3. So here expect observation will be, you see when you add dilute nitric 5 acid in lead 2 carbonate, you will observe effervescence of colorless gas. Why? Because lead 2 carbonate plus nitric 5 acid will liberate carbon dioxide, hence effervescence. And the wooden splint, the burning wooden splint will go off. Why? Because carbon dioxide extinguishes the burning splint. So that is now the expected observation. Effervescence of colorless gas or Kcse that extinguishes the burning splint. Now in our second test, which reagent are we going to use in the second test? We are going to use aqueous ammonia. So you describe by saying to the first portion, you add aqueous ammonia dropwise still in excess. Aqueous ammonia comes first. Why? Because it is a main reagent compared to aqueous sodium sulfate. So test 2, you say to the first portion add aqueous ammonia dropwise still in excess. So what will be the expected observation? So you see you are given lead ions. So you need to know the relationship between lead ions and aqueous ammonia. Lead ions forms white precipitate insoluble in excess with aqueous ammonia. Therefore, expected observation is white precipitate is formed which is insoluble in excess. So the reason is you have lead ions there. You are analyzing lead ions. So lead ions forms white precipitate insoluble in excess with aqueous ammonia. Now under test 3, now you have used aqueous ammonia, solid K, wooden splint, then dilute nitric 5 acid. So here you are remained with the aqueous sodium sulfate. So you say to the second portion, add 3 drops of aqueous sodium sulfate. Good. So you need to know the relationship between lead ions and sodium sulfate. Lead ions forms white precipitate with sodium sulfate because lead sulfate formed is insoluble. So the observation is white precipitate is formed. So you take now, you have used aqueous sodium sulfate. So that's now the descriptive procedure. You have described the procedure. So we'll use this procedure now to carry out the test in question B. So question A, you are only describing the test using the reagents that you are given. Remember our first procedure was to solid K in a test tube, add dilute nitric 5 acid and test any gas using a burning splint. And you divide the resulting solution into 2 portions for use for test 2 and test 3. So let us do that. Then you add dilute nitric 5 acid. Make the observation there. So check the observation there. See there is effervescence there occurring. And then the wooden splint, the burning wooden splint extinguishes. So let us make that observation now. Write the observation. The effervescence of colorless gas occurs. That extinguishes the burning splint. Good. So the inference now becomes effervescence indicates a gas, production of a gas, and that gas extinguishes a burning splint. Therefore, the inference becomes carbonate ions present. CO3 2 negative. Good. Now we proceed to test 2. So we go back to our description. In test 2, you are told to the first portion add aqueous ammonia drop white still in excess. So let us do that. So that's another first portion. Aqueous ammonia. So that's now white precipitate in excess. you will get white precipitate insoluble in excess. So let us write that observation. White precipitate is formed which is insoluble in excess. So the inference is aqueous ammonia, when you get white precipitate insoluble, you are supposed to infer 3 ions. That's magnesium, aluminium, and lead. But aluminium, because there we said carbonate ions present, therefore here if you infer aluminium, it becomes a contradictory statement. Reason? Because aluminium carbonate does not exist. Therefore here you infer either magnesium or lead ions present. Remember, aluminium carbonate does not exist. Therefore, that's the reason as to why we are not inferring there. So now this is the second portion. This is another second portion. So let us carry out that description. What are we told in our second test? Second portion, add 3 drops of aqueous sodium sulfate. So let us do it. Sulfate. So as you can see, there is no white precipitate formed there. So you write no white precipitate is formed. So remember, sodium sulfate does test 3 ions, that is calcium, lead, and barium. So it forms white precipitate with calcium, lead, and barium. And there, in our above inference, we had magnesium or lead. So since now lead forms white precipitate with sodium, then here we say lead ions absent and magnesium ions present. Therefore, here we infer magnesium ions confirm present. Ions absent. That's the end of our analysis. Remember, we are told that it was suspected to be lead carbonate. Here now we have confirmed that it was not lead carbonate. Instead, it was what? It was magnesium carbonate. That's very good. So that's the end of question 2. Thank you for watching. For more videos, make sure you follow us.